Now it's day 4, it's time to get random. And while Arduino isn't the most powerful microcontroller, it does have the ability to do math. And one of the key ways that we can use this randomization is we can do effects for props and cosplay and even Christmas lights. So we start with what I'm calling a sci-fi dashboard, and you may be familiar with the effect if I show you an example.
We want you.
Who? Who did you say you want?
We want the robot.
Oh, thank heavens. What are you waiting for? Find out what the gentleman wants.
He who turns and runs away may get his information another day.
As you can see, I'm using 3 LEDs for this, but obviously you can use more, and probably the more you use, the better the effect is going to be. But for now we'll use 3, and we assign them to, again, 10, 6 and 9. And they're just 3 of the PWM pins, the ones with the tilde to the side on the labels. In setup, we have to seed the randomizer, and that is because the microchip that we're using cannot actually do true random. And if you don't randomize it using some sort of input that is going to give it a different result every single time, you'll find that you get the same results over and over because it's pseudo-random. It's not actually completely random. So by checking the floating input on pin 0, we can actually get a result. And as you can see, this is something that they actually advise on the Arduino reference, to just check the value from an unconnected pin. So in my case, I'm doing exactly what they said, pin 0. And then we set all 3 pins to output, and in the loop we check the random number for each brightness. So the LED 1, LED 2, LED 3 will get a value between 0 and 255. You can actually miss off the 0 if the number is between 0 and a number, but I find it more readable to say from and to every time. So it's a matter of taste. And then we apply that brightness to each pin. So we'll randomly light up and dim each one. We'll have the pin bright, the LED bright, for a random amount of time between 0 and 250 milliseconds. We'll turn it off, and again we'll delay for a random number between 0 and 250 milliseconds, and that's what gives it the blinking effect. Now you'll notice that when the LED is blinked on and off very, very quickly, it looks like it's on full, or it's on but it seems dim, and that is exactly how this brightness works. It's PWM, so it's not actually sending an analog value. What it's doing is sending the current and turning it off so quickly that the eye cannot detect it, and that's because of persistence of vision. So because it's turned off and on so quickly, it looks static to us. It looks like it's just on all the time. Now we should switch gears and take a look at the first version of the Magic 8-ball sketch. What this is going to do is it's going to pick a random response from the 20 that are listed on the Wikipedia article, and it's going to output it to the serial monitor. And this demonstrates a few things, and the first is lists, which are called arrays. So we set it up at the top so it's global. It means that it's accessible from anywhere in the sketch, and that's not super important in this first version, but It's a good practice to get into to work out whether the variable needs to be only accessed locally within the function or the loop, the setup, or if it needs to be accessed from everywhere in the sketch. And this needs to be accessed everywhere in the sketch. And you can see it's a string, and what a string means is text, words, and so we call it responses, and the square brackets here say it's an array. And then we give the array, using the equals, the values, and it's a list separated by commas. And because it's a string, it has to be surrounded in quotes, and they have to be straight quotes. So when you're copying and pasting, make sure you don't copy the fancy curly quotes that look like 66 and 99s. It has to be the straight inch symbol. So we've got 20 here, but we don't have to specify how many we've got. In this case, we just have to give it the values separated by commas and then close the curly brackets and put a semicolon. And then the way this is going to work is it's going to give us one answer, one result every time we restart, reset, or turn on the Arduino. We set up the serial again at 9600. It doesn't have to be super quick because all we're going to do is output some text. We do a blank line, then we do some dashes just as a little separator. We say welcome adventurer. That's just a silly phrase, just show that it's starting. And then we pick a random result from that list. And again, we have to seed the random to make sure that we get different answers every time. And just as an exercise, comment that out or miss it out, delete that line, and see if you do get different results every time. And then we say we want a string called selected response based on that random number between 0 and 19. Weird thing, arrays don't start at 1, they start at 0. So it goes 0, 1, 2, 3, 4 until you get to 19. So there's 20 slots, but the first one's numbered 0. And that can trick people, catch people out. The top result isn't in slot 20, it's in slot 19 because we start at 0. And here we have something we haven't seen before. This is a new line character, and it's denoted by the backslash. So in a string we can say \n, which is a new line character. So it's like pressing return on your keyboard. And then we concatenate, we use plus to say add the selected response to this string, so we can output it all in one line. So you could output different lines like this, and this essentially sends a new line character because all of these, when we're doing print line, they have the new line character added automatically. But this is just another way of doing it, so we can have another new line. So if you wanted to have two new lines, you would do 2/ends and then the selected response. And we have an empty loop. It would bug out if we didn't have this at all, but we have an empty loop because we're only going to run it every time we hit reset. So let's see what the result is when we try it out. Most likely, without a doubt. Yes, all positive so far. Oh, my reply is no. Okay. So we're getting random results and it's outputting. Now, to take it a little bit further, if you actually go to the Wikipedia article, you'll see that it has affirmative, non-committal, and negative. And that made me think, well, what about lighting up LEDs? This version has LED lights. So we have 3 pins as before, and our responses now is a 2-dimensional array. So we can have unlimited rows, but we've said we've only got 2 columns. Each row has the column for whether it's affirmative or positive, and then the text that is associated with it. So that means for each of these we've got how positive it is, and then we've got the phrase that we want to output. And in setup, we set the pins to output, we set the serial to 9600, we output the intro, the header, we randomize, we random seed, we pick a number between 0 and 19, and then we get the value for how positive the result is from the first column 0, column 0, and we get the response from the second column, column 1. Remember, the array starts at 0, so the second column is actually column 1. Then we output those results to the serial monitor, and we have something else that's new here. We say if the selected positivity is 2, so equals is the value matching, is the value equal to. Don't make the mistake of only having 1 equals, because that will assign the value instead of check it. So if selected positivity equals 2, then we want to set the color to green on our RGB, or light up the green LED. Otherwise, if the result is 1, then we want amber. We want it to be yellow. And otherwise, if it's neither of those, then we want it to show red, because that's bad, that's stop, that's a negative. So this is an if statement. It's deciding what to do. If selected positivity is 2, do this. If it's 1, do this. Otherwise, show red. And again, we don't have a loop.